Today's lesson is part 3 of section 2.2. Our only objective for today is to examine a data set and determine if it's approximately normal, and I'll show you several different ways to do that. So here's our data set for today. It gives measurements of usable capacity in cubic feet of 36 different side-by-side refrigerators, and I'm wondering if these data are close to normal. So hopefully you already have these data in your calculator, and if you do not, you should pause the video and do that now. So method 1 is really simple. It's to just make a graph, a histogram, a dot plot, or stem plot on your calculator and determine if it's symmetrical and single peaked. So you should pause the video and do that now. Here's the histogram that I got, just not setting the bin width or anything, just letting the calculator graph it. And yes, this distribution does seem to be single peaked and symmetrical, so the distribution of usable fridge capacities is approximately normal. Now notice that I didn't say it's exactly normal or just normal, I said approximately. So no, it's not exactly normal, but it's really close. So let's see if we can add something to that to kind of confirm that decision. So one thing that I can do is just check to see if the data follows the 68, 95, 99.7 rule. So here's what you should do. You should calculate one variable statistics for this data set, and then redraw the histogram, letting the bin width be the standard deviation. Now round that to 3 decimal places just so that we're pretty accurate here. And then for your left alignment, what you would like to do is make the left alignment be whatever that whatever the mean is, minus 3 times the standard deviation. That'll give you the leftmost endpoint for 3 standard deviations below the mean. So try that now. Pause the video and set up your histogram so that it's counting by the standard deviation as the bin width from the leftmost endpoints 3 standard deviations below the mean. So here's what my histogram looked like. And so I just put my cursor over each of those bars, and I found that within, if you do X bar plus or minus 1 sigma, I found that there were 24 out of the 36 observations within 1 standard deviation. So that gives you about 67% of the observations in that range. And then if you look at X bar plus or minus 2S, I found that there were obviously the 24 that we already had plus 10 more. So that gave me 34 out of the 36 observations for 94%. And then if I looked at X bar plus or minus 3S, I actually found that all 36 of the observations were in this range for 100%. So this distribution of fridge capacities roughly follows the 68, 95, 99.7 rule. So my decision of approximately normal is confirmed. Okay, and so that was pretty easy. Now one more thing that I think sometimes is very helpful, and that is our second method for determining if a data set is approximately normal is to construct a normal probability plot. A normal probability plot plots the data values on the x-axis, and then it plots the z-scores of each data value on the y-axis. If that plot is close to linear, then that means the data are approximately normal. If I have some kind of severe curvature to that normal probability plot, that means that my distribution is non-normal. If you see points that just lie kind of far away from the overall linear plot of the normal probability plot, then that would indicate outliers. So let's try this. Pause the video and then go to the histogram that you already have drawn on your calculator and just press menu and plot type, and you'll see normal probability plot as one of the plot types. So choose that. It'll automatically set a window for you and see if it looks approximately linear. So here's the graph that I got. This is the normal probability plot. So I'll write something like this. You can see that it's really, really close to linear. So I'll say something like, since the normal probability plot is close to linear, my decision is confirmed that the distribution of fridge capacities, usable fridge capacities I should probably say, is approximately normal. I'll just caution you about using the word it. You want to talk about the normal probability plot and then the distribution of the data. Many students will say something like, since it is linear, then it is approximately normal. And the its are actually talking about two different things there. So you have to be very clear what it is that you're talking about that's linear and what it is that you're talking about that is approximately normal. And don't forget to use context in your explanations. Okay, you should now go try the online quiz.